We present VisLab, an online system that enables visualization designers to gather empirically informed feedback on their designs. Data visualizations surround our lives. We come across millions of data visualizations on the web. Some of them are good and bad. Some of them are weird. The designers of these visualizations are faced with intricate design factors, which include perceptual effectiveness, aesthetics, engagement, and memorability. Empirical research in visualization can offer useful knowledge for practitioners to help make informed design decisions. But they are insufficient to cover combinatorial design space in the wild, including many other contextual factors. As a result, practitioners frequently rely on hunches to make nuanced design decisions. Such decisions involve heterogeneous data distributions, unconventional visuals, and narrational elements. Some of these are not typically found in empirical research. To understand their design practice, we ran a brief survey with 18 practitioners from the Data Visualization Society. All of them said that they have been in a situation where they needed to make decisions among conflicting design alternatives. Around 80% of them said that they run into this situation almost always. To resolve design conflicts, they said they look for examples, ask colleagues, or rely on gut instinct. This confirmed our hypothesis that the current feedback practice is mostly ad hoc based. So we thought, how might we help practitioners derive objective feedback? We observed savvy practitioners create experiments to test their design ideas. Here is an example of such an experiment demonstrating the comparison of different bar styles by a leafholder. We then thought, what if we enable practitioners to create quick turnaround tests to derive quantitative feedback? To address this issue, we developed VisLab, where individuals can test competing visualization design ideas by borrowing methodologies from empirical research. To inform the design of VisLab, we analyzed existing experiments to derive a streamlined experiment procedure that is amenable for practitioners. VisLab currently supports 3 experiment scenarios that are generalizable across different visualization types. We derived these from the empirical research literature. They include graphical perception, attention tracking, and memorability. We initially chose these 3 to capture a holistic visualization experience from perceiving a chart, extracting its meaning, and storing the message for later retrieval. Let us briefly explain the user workflow in VisLab. Here is a list view of existing experiments created in the past. To create a new experiment, click the plus sign, which opens up a list of available templates. We will use a graphical perception experiment to demonstrate the user workflow. Upon clicking the template, it goes to the authoring interface. The authoring interface is clearly divided into different steps from introduction and tutorial to task interface and surveys. The task interface is the core part of the template, while other components are the same across the templates. The user can start by dropping their visualization design alternatives. VisLab currently supports images or bigger lights. Thus, it can support interactive visualizations as well. For graphical perception, the user needs to supply questions they want to ask about the visualizations. These questions encode what they want to convey to the audiences. The demographic survey is optional, while we provide several default questions. Post-survey can be used to collect qualitative feedback such as user preferences. The designer user can preview the experiment. To deploy the experiment, VisLab generates an online link to the experiment. We check participant IP to prevent duplicate participation. Anyone with link access can participate in the experiment. The figure on the left shows how the experiment would look like to the participants. And the figure on the right shows the experiment result page for the participants. They can see their overall results in comparison to other participants. Once the experiment is complete, the designer can inspect the outcome in the dashboard. VisLab measures task and accuracy for the graphical perception experiment and presence means and confidence intervals in the dashboard. Scrolling down, they can also see the performance broken down by each task question. Clicking the demographic factor, they can also see the result by demographic factors if they had a demographic survey. They can also inspect individual results. This is helpful to detect malicious participation. We also automatically flag outliers based on interquartile ranges. Attention tracking and memorability experiment templates have similar procedures. Attention tracking allows users to track readers' mouse clicks that simulate eye movements. Memorability experience can tell which visualization design may help better recall of information in the visualization designs. You can find more details in the paper. VisLab also comes with knowledge sharing and remixing features. They can tag each experiment with metadata such as chart types and task types. They can explore experiments created by others and inspect the results. If they want, they can remix existing ones to create new experiments. Next, I will present two evaluations, starting with an evaluation of internal validity of VisLab. We reproduce the results of existing studies that we utilize for the templates. When we compare these two charts in VisLab, we find bar chart remains perceptually effective when it comes to finding a value or deriving the ratio of bigger to smaller. We also found the click maps generated in VisLab in the attention tracking experiment is comparable to the original result. When we tested two most memorable and least memorable images in VisLab, their memorability rankings remains the same. Next, we will present user study results. We ran a usability study with 10 practitioners going through 3 tasks from replication, reproduction, and creation tasks. Only 3 invited participants went through the creation tasks. Here are the outcomes of the creation tasks, where we provide a dataset and the 3 participants created visualizations and run 3 experiments to derive feedback. They experimented with different bar chart variations and an area chart. Participants also shared their thoughts and comments regarding VisLab. First of all, they appreciated the value of templates, making it easier to follow the experiment flow. The templates lowered the barriers for practitioners who are not researchers. They also liked the dashboard, helping the interpretation of the outcome without statistical knowledge. P1 and P6 who participated in the creation tasks, they reflected on the outcome in the dashboard. They gained comparative insights between bar and area charts, as well as where people looked at in the chart area. They also commented on the potential benefits of qualitative forms of feedback by saying it would be easier for people to provide feedback, and also the outcome might be more objective. Lastly, participants commented that remixing can allow for reusing other people's task questions to get started. They also commented that it can be good for tracking and comparing different experiments, as well as archiving knowledge accrued from multiple experiments. Participants also commented on the limitations of VisLab and future opportunities. They commented on evaluating different aspects of visualization design, such as aesthetics, and extending the capability of an existing template, such as being able to ask questions for attention tracking. They also commented on the capability of doing advanced statistical analysis and exporting data to external tools. For the latter, we added data export afterward, and also more precise control over the types of participants. For this, we added the ability to link with external crowdsourcing platforms, including Prolific. We believe VisLab is a step toward fostering a community around visualization design knowledge. As one participant commented, the applicability of existing guidelines to their design context is often not clear. VisLab can help fill this knowledge gap between practice and research. On the other hand, experiments run by practitioners can offer useful initial hypotheses to researchers, providing hints about what practitioners are interested in. Researchers can test practitioners' ideas in rigorous lab environments to provide generalizable knowledge back to practitioners. Thank you for listening to the talk.